What if I told you there's a single, simple physics principle that powers almost every machine you interact with every single day? From the car you drive, to the blender in your kitchen, even a simple can opener. It's not some complex quantum theory or a secret kept in advanced labs. It's a beautifully elegant concept that ancient civilizations mastered thousands of years ago, and it's called mechanical advantage. Sounds a bit technical, right? Don't worry, it's incredibly simple. At its core, mechanical advantage is all about trading distance for force. Think about it like this. Imagine you need to lift a really heavy rock. Trying to lift it straight up with your bare hands is tough, maybe even impossible. But what if you grab a long, sturdy lever, like a crowbar, and place a smaller rock underneath it to act as a pivot point? You push down on the long end of the lever, and suddenly, that impossibly heavy rock lifts up with ease. What just happened? You didn't magically get stronger. You simply applied a small force over a long distance at your end of the lever, and the lever transformed that into a large force over a short distance at the rock's end. That's mechanical advantage in action. You're essentially multiplying your force. This fundamental idea is the secret behind what we call simple machines. There are 6 classical simple machines: the lever, the wheel, and axle, the pulley, the inclined plane, the wedge, and the screw. Every single complex machine, no matter how high-tech, is just a combination of these basic building blocks. Let's break them down. We've already talked about the lever. A seesaw is a perfect example. A bottle opener, a pair of scissors, a wheelbarrow, all levers. Next up, the wheel and axle. Imagine trying to drag a heavy box across the ground versus putting it on a cart with wheels. The friction is drastically reduced. A single pulley just changes the direction of a force. This is how cranes can lift massive steel beams and how sailors can hoist giant sails. They are pulling a lot more rope, trading that distance for the ability to lift immense weight. Now, for the inclined plane, you know this as a ramp. Pushing a heavy object up a gentle ramp is way easier than lifting it straight up. Wheelchair ramps, loading ramps for trucks, and even winding mountain roads are all inclined planes, designed to make moving upwards easier. A wedge is basically 2 inclined planes, put back. Think of an axe head or a knife blade. When you strike a log with an axe, the sharp edge applies a huge splitting force sideways, perpendicular to the direction you're swinging. The wedge converts your downward force into a powerful outward force that splits the wood. A simple doorstop is a wedge. Your own teeth are wedges. Finally, the screw. A screw is essentially an inclined plane wrapped around a cylinder. Look closely at the threads of a screw. It's just a tiny ramp. As you turn the screw, its threads pull it into the material. It travels a long, circular path. But in doing so, it generates a massive clamping force, holding things together with incredible strength. Jar lids and light bulbs are also examples of screws in action. So, you see, these 6 simple principles are everywhere. Your bicycle is a masterpiece of mechanical advantage. The pedals and crank are a lever system. The chain and gears work like pulleys, allowing you to trade speed for power when going up a hill. And of course, you have the wheel and axle. Let's look at a car engine. The pistons move up and down, but a crankshaft, which is a complex series of levers, converts that linear motion into the rotational motion that turns the wheels. The transmission is a complex system of gears which are essentially wheels, with teeth that allows the driver to change the mechanical advantage between the engine and the wheels. Lower gears give you more torque, more force, to get the car moving, while higher gears trade that force for speed. Even in our digital world, this principle holds true, just in a more abstract way. Think about algorithms that compress files. They find clever ways to represent large amounts of data in a smaller space, trading computational effort during compression and decompression for a smaller file size. It's a different kind of trade-off, but the spirit is the same. Do more with less effort. The beauty of mechanical advantage is that it is governed by a fundamental law of physics. The conservation of energy. You can't get something for nothing. You can't create energy. When you use a lever to lift a heavy rock, the work you do is the force you apply, multiplied by the distance you move the lever. That amount of work is equal to the force exerted on the rock, multiplied by the distance it moves. Since the rock moves a much shorter distance, the force on it must be much larger. Energy is conserved. You just changed how it was applied. So the next time you open a jar, ride a bike, or even just turn a doorknob, take a moment to appreciate the genius of mechanical advantage. It's the invisible physics trick that has built our world, making the impossible possible, one simple machine at a time. It's a reminder that sometimes the most powerful solutions are the simplest ones, hidden in plain sight, all around us. Thanks for watching. If you enjoyed this dive into the physics of everyday life, don't forget to hit that like button and subscribe for more content. Let me know in the comments what machine you'd like me to break down next. See you in the next video.